Okay, so basically what we have at the moment is that if r is greater than 1 and r is less than 1, then the limit of r to the n doesn't exist. Okay? So an example would be if r was a number like 3. As 3 gets bigger, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27. We can see that it's just going to constantly get bigger. Likewise, minus 3 to the power 1 is minus 3, minus 3 to the power 2 is 9, minus 3 to the power 3 is minus 27. It alternates signs, but still ultimately going further and further away from 0. Okay? So what we say is that the sum of infinity is if you were to get, like, that's S1, that'd be S2, that'd be S3. The sum of infinity is when we're adding plenty of terms. You can see that this is going to be a very large number that won't stop. Okay, so if a limit exists for Sn, it's said to be convergent. If a limit doesn't exist, it's said to be divergent. Okay, so that's what we got to learn about series there. Okay, now another thing to note is that the limit of any fraction, any proper fraction, such as let's say 2/3 to the power of n equals 0. So 2/3, if I was to make a table of 2/3 for instance, so f of x equals 2 over 3 to the power of x. Okay, and I said I would start at 0, go up in, I don't know, tens, and end at 100. Now look what happens to the figures. We got 1, and then we got nothing after that. Okay, so let's try this again. 1, start at 1, we'll end at 5, we'll do a step of 1. Look at this, 1, 0.6, 0.4, 0.2, 0.9. We can see that it just keeps getting smaller and smaller and smaller. Okay, so that's what it means to be the fraction there. Okay, now the sum of infinity of a geometric series can be presented as this formula here: S0, S infinity equals your original value 1 minus the common ratio if your ratio is a positive fraction or a negative fraction. Okay, basically its modulus value is less than 1. That's basically what that means there. Okay, so let's start off with question 6 followed by question 9. Okay, so in question 6 our a value is 3 over 2. Our r value is t2 divided by t1, which is minus a quarter divided by 3 over 2. So minus a quarter divided by 3 over 2, or just do a quarter divided by 3 over 2. And then what we get there is a 6. So r value equals minus a sixth. Okay, so what we had to do is have to find the sum of infinity. Sum of infinity equals a divided by 1 minus r. That's going to be 3 halves divided by 1 minus 1/6. And what that's going to be is 3 halves divided by 7 over 6. So then we do 3 halves divided by 7 over 6. So 3 halves divided by 7 over 6. And what we get there is 9 over 7. So the limit of this one is 9 over 7. The limit of the series. Okay. So the next one then is question 9. And question 9 is going to be 2 plus 2a over 3 plus 2a squared over 9. Okay, plus dot dot dot. Now, in this case, the initial value is 2a, or the a value, so to speak. This is the initial value. A is 2 over 3, and then we can find out what r is by dividing t2 minus t over t1. Is 2a over 3 divided by 2. And this means that our r value is a over 3. R equals a over 3. Now that we've determined that, then we're going to do S affinity. S affinity is our initial value of A divided by 1 minus R, which ends up to be 2A all over 1 minus A over 3. And what that will be is simply, we might get a common denominator there, so we'll put that as 3 over 3. So it's going to be 2A divided by 3 minus A all over 3. Then we can bring this upside down, 3 over 3 minus A. So then it's going to be 6A divided by 3 minus A. I'm sorry, just a quick adjustment on that. Actually, the A value is actually 2. So it's not 2A, it's actually just 2. So this here isn't actually going to be, there's no A there. So it's actually 6 over 3 minus A. Excuse me, quick mistake there. Now, moving on. Evaluate the following. So I'm going to evaluate is question part 2. Part 2, okay. What 10 part 2 says is, so I'm doing 6, 9 and 10. So 10 part 2 is basically saying, look, your terms, UR or UN, is basically 3 by a half to the power of n. I have to find out, the E means the sum, and I have to start off at n equals 0 and end at n equals infinity. So it's the sum of infinity series, okay? So what I have to do is I have to find out what my A value is. My A value is my first term. My first term, according to the bottom here, is U0. U0 is 3 times a half to the power of 0, which is going to be 3. Okay? And now I have to find out what my R value is. So A equals 3. Find out what my R value is. So I'm going to find out what U1 is. So U1 is 3 by a half power 1, which is 3 over 2. If I really wanted to find out what U2 is, I could say 3 times a half squared, and that will get me 3 over 4. So you can see that the R value is multiplying by a half each time. So R equals a half. Now all I have to do is use the SN formula. SN, because I have to find out the sum of infinity, which is going to be A over 1 minus R, which is going to be 3 minus 1 minus a half. 3 divided by a half, and the answer there is 6. Okay, so now we're on 10 part 3. Now in 10 part 3, what we have is 10 part 3, we have the sum of infinity, n equals 0, x into 1 minus x to the power of n. Okay, so we have to find out what's going on this time. Once again, U0 is x multiplied by 1 minus x to the power of 0, which is any number to the power of 0 is 1. So the U0 is x, that's the first term, and that's A, because n equals 0 is the first term. U1 is the second term, so to speak, and that's going to be x times 1 minus x. The third term, which is technically U2, is going to be x 1 minus x squared. So we can see it gets multiplied by 1 minus x each time. So the R value is 1 minus x, and the A value is x itself. So now we're going to find out the sum of infinity, because it says infinity up here. So sum of infinity, just to be dead certain about this, just to show you. You can see it's the sum of infinity. Okay, so the sum of infinity equals A divided by 1 minus R, which is going to be x divided by 1 minus 1 minus x. It's going to be x over x, and that equals 1. Okay, in the next question, in questions 12 to 17, express the recurrent decimal in the form a over b, where a, b is the element n. So what we can see here is that it's 2.22222 with dot on it. It's just going to go on for 2 forever, okay? So what I'm going to do is we're going to rewrite this as a series. Right? So it's going to be 2 plus 2 over 10 plus 2 over 100 plus 2 over 1000 and all the way on till infinity. Okay. Now in this question here, okay, what we can say is that it's the so that's that one, and this one's this one there, right? So what we can say is that it's a series. Our a value is 2, our r value is 1/10, and the sum of infinity is basically a over 1 minus r, which is going to be 2 divided by 1 minus 1/10, which is going to be 2 divided by 9/10, which is going to be 20 divided by 9. And let's check out what 20 divided by 9 is in the calculator. Lo and behold, 2.2 reoccurring, or 2.22222. So that's how we do that one, okay? Now we're going to move on to question 14. Okay, so in question 14, what we have is 0.72 reoccurring, 0.72, so reoccurring on both of them, so it's going to be 0.72, 72, 72, 72, 72. Now this one is, if you take the first two, it's 72 over 100. The next two are technically 72 over 10,000. Because that's 7 thousandths, that's two 10,000ths, so it's technically 72 10,000ths, and after that you're going to have 72 over, so that was 10,000, that's 100,000, and that's a million, so 72 over a million. Okay, and then you can stop there and continuing on. Now our a value is 72 over 100. Our r value is basically 10,000 divided by 100. So 10,000 divided by 100. And what you're going to get is 100. So r equals 1 over 100. Then you're going to get s infinity, because these decimals keep going on forever. So it's going to be equal to a divided by 1 minus r, which is going to be 72 over 100 divided by 1 minus 100. Which is going to be 72 over 100 divided by 99 over 100, which is going to be 72 over 99, which is 8 over 11. So let's see how, if 8 over 11 works. And 72, 72, 72, 72, 72. Okay, so that's that one done. Now we're on question 17, okay? And on question 17, what we're going to be doing is, it's going to be 1.833333. The decimal recurrence is here. So we're going to do is we're going to get 1.8, and that's going to be plus 3 hundredths plus 3 thousandths plus 3 10,000ths, and continuing all the way down. So the series is technically this part here. So we're going to find out the sum of all of these numbers added together, where a is equal to 3 over 100, and r equals, it's going to be 1 over 10 each time. So s infinity this time is going to be a into over 1 minus r. It's going to be 3 over 100 minus 1 minus 1/10. It's going to be 3 over 100 divided by 9 over 10. So it's going to be, let's do that in the calculator there. So 3 hundredths divided by 9/10. That's going to be 1 over 30. Okay, so that's going to equal 1 over 30. So this whole system here This complete system is equal to 1 over 30. So now it's going to be 1.8 plus 1 over 30. Okay, so 1.8 plus 1 over 30. And what do we get there? 11 over 6. And what is 11 over 6 in the calculator? 1.8333. So it's 11 over 6. Is the answer for this question here. Okay, so that's number 17 done. Okay, so question 19. The sum of affinity of a geometric series is 4. So A over 1 minus R, which is the sum of affinity, equals 4. The first term is 6, so we can replace A with 6. Then we can cross multiply, we get 6 equals 4 minus 4R. Multiply up by 1 minus R. Then bring the 4 over the other side, and we're going to get 2 equals minus 4R. Divide by the minus 4, R equals 2 over minus 4, R equals minus a half. Okay, so that's R equals minus a half, the common ratio. Okay. Now, if the sum 21, if the sum to infinity of a geometric series is 5 times the first term, find the common ratio. So once again, the sum of infinity is A over 1 minus R. Okay, sum of infinity of a geometric series is 5 times the first term, find the common ratio. So, and that's going to equal 5 times the first term. First term is always A, second term is AR squared, so it's going to be equal to 5A. So what we're going to get is the A's cancel on both sides. We get 1 over 1 minus R equals 5. Cross multiply, 1 equals 5 minus 5R. Bring the 5R to this side, that to the other side. We're going to get 5R equals 5 minus 1. 5R equals 4. R equals 5 over 4 over 5. Okay guys, so that's the end of this video.